Hello, everybody. How are you doing?
Morning, everybody.
Great.
I'm just gonna adjust here. So everybody, feel free, turn on your cameras and your microphones and all matter of technology that you have. We're gonna chat and I want to hear from everybody what you have to say and your ideas. I'm going to share some things that that I've got. Talk a little bit about what Ebips are, but I want this to be a engaging conversation. So we'll give everybody 30 seconds or so to join in, and then we'll get going. Good group. I've seen a couple of you in previous sessions and a couple of new faces, so glad to see you back. Some of you will hear some things that you've probably heard in other sessions. There's a lot of overlap in a lot of the content that we talk about here in the TLPDC, specifically within my program for sure, which is the STEM Teaching Engagement and Pedagogy program. So, but there will be a lot of STEM references in my talk today, but all of this works across all disciplines. So I want to make sure that that's clear. There's Neo. Hey, Neo, how you doing? Good to see you. So we'll go ahead and get started. Can everybody see and hear me okay? Okay, good deal. Very good. So I have some PowerPoint that I'm going to reference, and I'll flash that up on the screen when it's appropriate. But I don't want this to feel like a death by PowerPoint kind of workshop talk. So I'll be referencing some PowerPoint. When appropriate, I'll flash over to the screen because I will show some data, some figures and things like that. But I want to try to keep this as conversational as possible. So basically, I'm going to kind of make this a four-part discussion. So what are Ebips, or evidence-based instructional practices, and what do the data say about those? What are some examples of Ebips? How do we implement those evidence-based instructional practices? And again, when I say implement them, I'm referencing kind of the ones, the top two or three. There's a lot out there, and there's a lot out there that are supported in the data, but it may not work for your class. So the ones that I'm going to bring up are those that span disciplines, are low-hanging fruit, they're easy to implement without a whole lot of practice, that sort of thing. And then finally, the fourth part is I want to hear what you're doing. I think we all want to hear what you're doing because I think that that's really important to see what you're actually implementing in your classes. And that's where I think we get the most of our ideas. So let's go ahead and get started here. I will go ahead and share my screen here. Excuse me. I'm just going to leave it in slide sort mode for the most part, so you'll be able to see it. Let's see here, share screen, and you should be able to see what looks like a web page. Can you all see that? Great. So this happens to be a, go ahead and see if it'll let me take it to, oops. Yeah, I'm just going to stay out of that mode. All right, so this is life science education. So if you're not a STEM person or a biologist even, because that's my background, you'll know that there are many main journals, like there are in any discipline, that we are all really kind of looking at as kind of the cutting edge of research. So this happens to be life science education happens to be a subsidiary of American Society of Cell Biologists, or the journal is called Cell, and that is in one of my worlds, that is the preeminent journal for bench research. Life science education is within that group of publications. And you'll see here, just looking at what they have on the screen, leveraging multiple analytic frameworks to assess the stability of students' knowledge in physiology. So it's very specific to a STEM course. So in this case, it's physiology. applying the stress process model to stress burnout and stress depression relationships in biomedical doctoral students. Again, very specific. That's a discipline that we typically refer to as DEBR. If you've ever heard that term, discipline-based education research, that is typically a acronym that is reserved for STEM disciplines. So there's math education research, biology education research, physics education research, and so on. Physics education research is really kind of the longest standing DEBR discipline. And so DEBR is basically the research component to a STEM specific experimental process for analyzing student outcomes, processes, teaching techniques, things of that nature. Again, I will say this is, DEBR is largely STEM, but it really spans across most fields. And in fact, you may have heard the term SOTL, Scholarship on Teaching and Learning. Depends on who you ask, there are differences between DEBR and SOTL. But generally speaking, they're very similar. I think the biggest difference when folks talk about SOTL versus DEBR that is brought up is that SOTL research tend to be thought more of as descriptive as opposed to quantitative. That's not always the case. There are very quantitative SOTL publications as well as very descriptive DEBR publications. So that's not really a fair assessment either. But like I said, if you really care enough to try and figure out the real differences, you can look at a lot of different teaching and learning centers across the country, and they'll weigh in on their thoughts on what's different about those. So here's another one. This is the International Journal of STEM Education. This is one that I'm actually a reviewer for. Again, this is, I think a lot of folks that are deep in their disciplinary work, which we all are, don't realize that there is a full-scale research arm to this type of scholarship. And so I just kind of wanted to point you to a couple of places. There's dozens of these types of, so American Chemical Society, ACS, they have a very specific journal. American Society of Engineering Education, they have a very specific journal. So my point here is that this is a thing, and a lot of faculty don't necessarily realize that this is a scholarship arm all in of itself. So I want to actually point out one very specific paper that is from 2014. Now, you'll notice on the edge here, on the margin of this is PNAS. So this is the Proceedings of the National Academy of Sciences. If you're not a STEM person, you may not recognize that acronym, but anything that's PNAS is a big deal. And so this was actually a meta-study, a meta-analysis, where these authors looked at, I believe it's 225 different papers on active learning. And we're going to talk in a second about what active learning is. They looked at 225 different papers to see if there was agreement among these papers. And, you know, I'll skip to the chase and say, yes, there absolutely was agreement in all these different papers. And I'll show you some evidence of that here in a moment. But I want to take a second and ask y'all what your interpretation is of active learning. What do you think active learning is? How do you interpret that term, active learning? And let's kind of unpack that for a moment. Anybody feel free to jump in.
Like for me, the basics is that I would like students to be like talking, at least to me, preferably to each other, about like concepts.
Thanks, Neo. Yeah, active students. You know, we can wish that we can just open their head and pour all the knowledge and new stuff in, right? And it would work that way, but we know that it doesn't work that way. So yeah, thanks, Neo. Other thoughts on active learning?
Hi, so it's Jody. I think of it as anything that's interactive.
Yeah, interactivity. I mean, it's kind of, it names itself, right? I've heard one faculty member who's a dear colleague say it's anything that's not passive, and so that's a very STEMmy way to to describe that. But to interpret his statement on anything that's not passive, I think what he means by that is students just sitting in a classroom watching you read your PowerPoint slides at them. I think that's what he means by passive learning, and I would agree with that assessment. So anybody want to give a specific example of something that they do in their class that they would consider to be active learning? Oh, Neo, you're muted.
I said I teach a lab, so I hope it's active learning.
Yeah, exactly. Yeah, labs, we really want to be active learning. But see, I'm glad you actually brought that up, because labs and studios, so over in art and architecture and other disciplines where there's a real kinesthetic component, those are intended to be application based, really, in a large sense. And so those kind of have to be active. So, oh, and I do want to make sure that I'm taking a look at the old chat box here. So, I can't look at the chat box because I'm presenting my screen. Erica and Mitzi, would y'all mind taking a look at the chat boxes just in case? Don, yeah, I'm sorry to interrupt you.
I'm on it.
Thank you.
Oh, you're fine. I was just going to say, because I teach pre-service teachers, of course, I have them practicing, like when they're doing a read aloud, they read those actual books to each other, to practice their strategies and questioning, that they would be doing with their students. But I also put them in small groups and have them do like, kind of like Freyr's model, like those concept maps, when we're talking about specific concepts that I really want them to focus on.
Yeah, fantastic. Good example.
And the one that I use the most in a discussion-based class is I think pair share, because I'm wanting to usually get people talking that normally wouldn't talk, or at least hearing the voice. Like if their partner was somebody who would talk a lot, if they say, oh, my partner said this, so that's the one, probably my easiest go-to one to do, where they have to really think about it, talk to somebody else about it, and then talk to me about it.
For sure. And we're going to unpack Think, Pair, Share here in a minute. And I'm going to give you some of the background as to why we know that Think, Pair, Share works. We know it works anecdotally because we do it all the time, right? But I'm going to share, and I know that you know this, Erica, but I'm going to share some of the data behind Think, Pair, Share, or specifically referred to as peer instruction. So I do want to go ahead and zoom in a little bit on this first page, where I've highlighted a couple of parts of the abstract that shows that when comparing straight lecture with active learning classes, students actually perform 1.5 times better in an active learning class. Another way to put that is that students are 1.5 times more likely to fail if they're in a non-active learning class. Now, I do want to give this caveat here. Whenever I do a workshop like this, where I bring up active learning or things of that nature, participants in that workshop think that I'm saying lecture bad, active learning good. This is not a dichotomy, a binary, right? That's not what I'm saying at all. Lecture has its place. Sometimes there's no way to get some information across unless you're lecturing, or else we'll never, get the information to the students. I mean, I know that there's the great debate of how much content do we put into our courses. Do we cover 10 chapters, 15 chapters, in some classes, 20, 25 chapters? And so there's no way to transfer some of that information without some form of lecture. I'm not saying lecture is bad, but I will say that lecture is a tool just like anything else. I mean, you would, if you're working on your house, you're not going to use a hammer for every job, right? You're not going to use a screwdriver for every job. You need a little tool kit that's got a hammer, a screwdriver, a saw, general things. Just like that in teaching, you need to be able to lecture. You need to be able to understand technology, at least a little bit. And of course, we'll talk specifically about how some of this stuff is going right now with all this distance learning. But you need some different strategies in active learning. And Erica brought up one called a think, pair, share. And we'll talk about that here in just 1 second. Here is something that is another piece of evidence from that Freeman 2014 paper from the National Academies of Sciences, where he actually saw that, excuse me, they looked at, and I'll get my cursor here, these increases in achievement hold across all STEM disciplines and occur in all class sizes, course types, and course levels. That is a real selling point for me when I'm trying to convince faculty that active learning works and it's helpful. The very first response I get is usually, well, that's not going to work in my class for this, and this reason. Well, my class is really big, or my class is really small, or I teach a lab, or I do a field class. This looked at all those different, this particular paper looked at all the papers that analyzed those different modalities, if you will, or types of classes. And they saw that it held across all of those different types of classes. And we see that, they say examination performance by just under improved examination performance by just under half a standard deviation, then lecturing increases. So we're talking like a grade, from a C to a B, basically, or a B to an A. And that's the real shift that we see. If we're thinking about a standard normal curve, the real shift that we see with active learning is the shift in the middle of the distribution toward up. So that's the real benefit to this type of learning. So you may be wondering about how active learning affects unrepresented groups. Well, there has been quite a lot of work done on this. Sorry, you might be able to see that. There's been quite a lot of work done in this, as you can see, Beichner, Freeman, Hake, Ballin, even up to 2019, and I'll specifically cite Elise Dallimore here in a few minutes, where she just published a paper in 2019 looking at Socratic questioning and benefiting underrepresented groups as well. So the bottom line is that active learning works, and here's some data to support that. So this KAI that you're seeing, that's the author's abbreviation for Knowledge Assessment Inventory. It's basically a pre-post diagnostic that they gave students. But if you look here, they're showing that both students, underrepresented students and non-underrepresented students, are actually gaining with active learning, but underrepresented groups actually improve disproportionately. So the take-home message of this is that everybody wins, but some groups win even more, if you look at it that way. And so this happens to be a particular diagnostic, and this happens to be the course grade over here on this figure. So I'll pause there because we're going to move into the examples component, and I want to see what questions you may have. I'm going to take a little sip here because I'm kind of getting a little, Okay. Is there anything popping up in the chat that we should address?
Some great, great ideas shared about different techniques and how they can be adapted and modified.
Awesome.
Based on different audiences, class sizes, modalities.
Great. Good deal. Okay, so some examples of evidence-based instructional practices. So Erica kind of primed the pump here on this idea of peer instruction. So peer instruction kind of defines itself, right? But the phrase or the term was coined by Eric Mazur. He's a Harvard physicist, and he's written several papers with colleagues on it. Nathaniel Lasry is usually the primary author on these papers. And what's really interesting is that they have looked at the efficacy of peer instruction at multiple types of institutions. So immediately you say, oh, if he looked at this at Harvard, then of course it's going to work, right? Well, maybe. But what he actually did was he looked at this at Harvard and at four-year colleges, at community colleges, at R1 institutions, at non-R1 institutions, at liberal arts institutions. What he did was he gave a fair shot at all different types of institutions to see if peer instruction was effective. And indeed, he found that it was. And again, I'm just going to share a brief clip to some of these papers. We're not going to read them all. And if you're interested, I can actually send all these links to you. I tend to want to send the links instead of the papers themselves, because that way the author will get the credit for the hit on having that paper looked at. But anyway, so this particular set of authors compared the effectiveness of peer instruction in two-year colleges with top-tier four-year institutions. And so here are some of their findings. So they saw that it was an effective instructional approach, not only at top-tier institutions, but at two-year colleges as well. Basically, PI, peer instruction, helps the DFW rate. I mean, if you really just kind of want to boil it down, cook off the water, it keeps students in the class. And there's a lot of reasons for that. And all the papers on peer instruction all have a slight different take on why that is, whether it has to do with loyalty to the professor, some sense of loyalty to their partners in the class, whether it's just that they're hearing things explained in a different way from a different voice. All of these reasons are reasons why, but some have a little more weight than others. So how do you implement PI? So that's the think, pair, share that Erica was talking about. It is the lowest hanging fruit there is out there. I mean, if you don't know, if you're nervous about trying to implement active learning in your classroom, whether it be face-to-face or online, and we'll talk specifically about that here in a second, you're like, oh gosh, I don't know if I want to try a jigsaw or a fishbowl, or all these cutesy little terms you hear. Those all sound too complicated, or I'm going to mess that up, or I'm going to get it wrong. Just do think, pair, share. You'll never get it wrong. It'll always work. So what is think, pair, share? So Erica's already told us that she uses think, pair, share. I'm wondering if maybe Jones would be willing to reach out, or maybe even Neo, or anybody else that is on the call would be interested in sharing how they implement PI or think, pair, share.
Can you hear me, Ken?
I can hear you, Jones.
I just transferred the sound to my phone now. I was trying to say something before it. You guys couldn't hear me.
I'm sorry. I can hear you now.
No, I'm dealing here with my technology. Yeah. So one of the things. So I guess I would add in before is when we can make that question and answering work in the class. I guess would be another way, a more simple way of active learning when you have tasks as well developed. So especially for the labs, I guess most of us that teach labs have tasks, right? So they do that in groups or whatever. So one of the things I could get my students more engaged, I guess, is when I have them answering questions that other students actually wrote. So some of the using less of my gadgets and more of the paper, so they would write on the paper and have basically a more difficult question, and usually I don't have any volunteer to answer, so they would write on that paper, and then they would switch that paper around that class, so they would lose track of it, and I would get students answering that with no fear. I guess it would be the proper way to put that. And as they didn't know who answered that, so then I kind of generated discussion inside class, because then somebody might agree, somebody might disagree, and as they didn't know who answered, they were more free to be interactive that way, I guess.
Yeah. So let me kind of give a little, thank you, Jones. Let me give a little background. So you're taking peer instruction, think, pair, share to kind of another level. So I want to make sure that I'm, because I think I know how you're using it, because I think we've talked about this, but let me back up and make sure everybody's on the same page. So think, pair, share is basically when you ask a question and you have students think about it for a moment, and then you have them pair with one another, talk over their answer, and then ultimately there's a report out, right? Now, I will, whenever I'm working with faculty that are new to this idea, I will often be very specific in how I recommend that they coordinate the pair component. So you want to make sure that you're asking a very specific question. And then when you pair them up, I use a term or a word that is very directive. A lot of times we'll say, okay, so now turn to your neighbor and discuss, or turn to your neighbor and talk it over, or turn to your neighbor. And those are fine, especially depending upon what the question was. I want to be even more direct in the way I use it. I'll actually say, turn to your neighbor and defend your answer. Because that is a way that students, hopefully during the think component, they have come up with their own response to that answer to that question. And then when they turn, maybe they'll have the same answer, but maybe they won't. And if they don't, I want them to be able to defend why they got it, why they got what they got. Okay. So what Jones is talking about is where he's kind of building a muddiest point component into a think, pair, share. You're like, oh gosh, another cutesy term. All right, so a muddiest point, if you don't know, is basically where you say, all right, students, take out a sticky note, or I will actually take kind of heavy paper stock, or not quite card stock, but just kind of heavier paper, and I'll slice it up on one of those bed slicers, and then I'll pass out stacks throughout the class. And I'll say, okay, we're going to do a 1 minute muddiest point. And so that's where, and I explain it to them early on, but eventually they just know what that means. When I explain it to them, I say, so what this is I want you to write down something that you don't understand at all from the last 10 minutes. So I've been talking for 10 minutes. I've been showing you 10 minutes worth of slides. What are you completely confused about? And so they take a minute or 30 seconds, however long you think that's going to take, or however much time you want it to take, and they write it down. Now, the problem is that they have now just admitted they don't understand something on a card, right? Which they're going to be hesitant to do. So the best way to move forward with that is have them pass it to a neighbor. And in fact, have them pass it a couple of times, so that card that has their point of confusion on it is somewhere other than immediately in the room. Now, of course, this technique worked differently 6 months ago than it does now. We'll have to think through how we would make it work now. But again, I'm trying to describe kind of the idea of what Jones is doing. And so then that person is anonymous. So then you can simply ask a student, Patty, would you please go ahead and read the card out loud that you have? Now, Patty doesn't care what's on that card because she didn't write it. That's the beauty of this technique. And so this is, I'm gonna hit you with another cutesy term. This is technically called a right pass. So you write it down and then you pass it. So this is all peer instruction. So it started with a think, pair, share, and then it was, well, you could say it started with a think, pair, share, and a muddiest point all at the same time, because the question was write down what you don't understand, that what I just talked about. And then you can have them pair up, or you can have them do a 1 minute kind of thinking process. They write it down, and then the right pass is they write it down and they send it over to the other part of the room. And so and you can actually get students discussing things Socratically, because again, their answer is just what they're reading on the card. It's not really their worry. And in fact, you can even ask the student if they, for instance, you can say, okay, everybody take a look at your card and let me know if you can answer this question. So that's an opportunity for a student to say, oh, so this is a really good question, and I think I know the answer to it. I see it happen all the time. And you know, I observe classes constantly and I see it all disciplines where it's working. So that's a lot. I've just fire hosed a lot of terms at you. Let's take a second and look at the chat, and I want to hear what y'all think. And I want to stop sharing my screen for just 1 second so that I can look at the chat. So I see that there's 20 notes here. Blackboard survey, yeah. Yep, exactly, Jones, thanks. So I will also say what I'm doing right now is something that was introduced by a researcher by the name of Mary Budd Rowe back in the 70s. This is wait time. I mean, it seems very simple, right? But what we tend to do in class is we'll talk, and then we'll say, are there any questions? And then we pause, maybe. And usually it's, are there any questions? Because I want to take a sip, right? Really what we should be doing is actually asking for questions. So a lot of times what we'll do is, you know, we recommend the TLPDC, we'll say, rephrase that. Say, what questions do you have, right? Oh, well, I can't just say no to that. Or you can, but it doesn't make any sense, right? So I'll say, what questions do you have? And then you pause. 3 to 5, 5 to 7, 7 to 10 seconds. It all kind of depends on the level of the course. Now, there's been a lot of follow-up research since the 70s when Dr. Rowe was doing her work on this. And in fact, some more recent work was where they said wait time is think time. And we know that think time or wait time varies with the age of the student, the level of the student, the rigor of the course. But there is a point of diminishing returns with wait time, as you might gather. So if I wait too long, then they pick this thing up and then they start doing that, right? So it's very careful that we give them a little bit of time to think, but then we monitor what's going on. So when you want to take that sip of coffee or water, make sure that you are holding them accountable for questions. So if you say, all right, what questions do you have? Take your sip, that's fine, but scan the room, and this is not an opportunity to check your phone or to adjust your PowerPoint or something like that. This is, if you need to do that, tell students you're going to do that, but this is where we want questions to happen. So that's what I did. I waited and asked for somebody to weigh in, and if you wait just long enough, somebody will fill the silence, because nobody likes silence, right? I will also point out something else that I did, and we're going to get to Socratic questioning here in a moment. So a few minutes ago, I wanted to know who had specific examples of peer instruction or think, pair, share, how they utilized it in their class. I actually used 3 names. I called on Jones, I called on Neo, and I think it was 3. Did I call on? Oh yes, Dawn. Yes. And so what I did was I didn't call on any one person, but I gave everybody notice that I was going to call on them, right? And so whoever happened to be ready out of those 3 could jump in. But if nobody was ready, then you know they have time now, and they can figure out what they want to say. The other way that you can do that is you can assign them a question in a think, pair, share, and you can observe what's going on, walk around the room. And again, these days it's a little bit different on doing that, but pay attention to what's going on when you assign them a question. Again, oftentimes I see this a lot during observations where it's great. The faculty member will pop a question on the screen and the students will get to work, and then the faculty member posts up at the old lectern and just kind of waits and doesn't take the opportunity to jump out into the class. That's when you need to go out there and find out what's going on. This is a formative assessment. You just ask them a question. Now you're going to find out if they understand or not. But this is when you have a chance to go out into the room and find out if they're understanding. Because if you're listening, you also have the ability to then start discussion, because then you can say, oh, Neo, yeah, that's a really great idea. I'm going to ask you to share that here in a few minutes. Okay. So boom. Then all of a sudden you've got, Neo knows that she's right. Neo got the, the props to, to say he thinks I'm a good student. And then Neo is likely going to start our discussion here in a few minutes. Right. So let me go ahead and talk about another level of peer instruction that we're actually working on here in the TLPDC. And this is called learning assistance. Now, learning assistance is not something that the TLPDC or the STEP program invented. Learning assistance actually started in early 2000s at CU Boulder, which is, I've never understood that. I have a colleague at CU Boulder, and he tells me he doesn't know this either, but it's University of Colorado Boulder, but they always call it CU Boulder. So I don't know why they do that. But anyway, CU Boulder is where learning assistance started. And it started off in STEM courses to try and improve DFW rates. And then we started to see it, it went from physics, and then it went to chemistry, and then it went to biology, and then it went to engineering, and then it just kind of blew up. And now actually here on at Texas Tech, learning assistance is now being implemented in English. And so this is a really cool pedagogy, which is, I wish I had thought of it. I mean, it's not rocket science, but basically what it is it's where you're embedding undergraduate students who have succeeded in the course previously into a live course. So there's a distinction between an LA and a TA. So a TA, as we all know, now in STEM, TAs typically will do laboratories and things like that. But if you're a non-STEM person and you have a TA, oftentimes TAs are tasked with grading or classroom management of some sort, proctoring, things of that nature. That is an assistant to the teacher, right? Which, don't get me wrong, I love my TAs. But a learning assistant is an assistant to the learner. And what that is that student, and we're doing this virtually right now in 2 classes, and it's working quite well, and I will talk about it if you like, because I think you can probably implement something like this in your courses. But what it is it's where a student who has gotten an A or a B in the class previously answers questions in real time from students in the class. So in other words, if you talk for 10 minutes and you give 10, 15 slides, whatever it is, and then you pause, and in your slide deck, you put a question. Now that question can be a problem, it can be a discussion, it can be whatever, it can be a figure, you want them to interpret a figure, whatever. And then you give the students 2 or 3 minutes to figure out what the answer is, or to discuss it, or to mull it over, whatever the assigned problem is. And that's where the learning assistants spring into action. So typically learning assistants just kind of sit there. But the second you assign something, then the LAs, then they start work in the room. And that can either be virtually via Zoom or physically in a classroom. And we train them pedagogically so that they're looking for confused looks. They're trying to prime students by asking probing questions, things of that nature. And what we have seen in some of the early data that we have from a chemistry course is that we saw a 6% improvement in DFW rate after 1 semester of learning assistance. Now, you're thinking 6%, that's whatever, that's not that big a deal, right? 6% in this course equates to about 35 students who passed who would not have otherwise. That's worth doing in my book, right? So, I love error bars as much as the next person, but when we're talking about students as opposed to error bars, I'm on board with anything that's going to mean 35 more students are going to pass my class. So that's some early data. Now, Dr. Brock Williams over in math, he's got some very specific data, and I won't share that because I don't want to, steal his thunder, because he's getting ready to present this in our upcoming conference, the Burns Conference, which, by the way, I hope you register for. he's going to present some of those data, and I don't want to steal his thunder here, so I want to just kind of tease you a little bit, but know that he is seeing significant improvements in his Calculus 2 course compared to previous iterations of his course without learning assistance. So I want to pause there because learning assistance is kind of a new topic to some faculty, and I want to answer questions and maybe help you figure out a way that maybe you can use some learning assistance in your class.
Ken, how often, how large are these classes typically when the learning assistants are very effective?
So the one that we have in Cal 2 right now is 120 students, and the one in chemistry is, I want to say 305. So they're massive classes. And so what we know from the literature, again, this is an evidence-based instructional practices workshop. What we know from the literature, and this was done at Florida International University, where they have got a robust LA program. We want to try to have a ratio of no more than 20 students to 1 LA. That's really the key. And so you have to flood the room a little bit when you have these giant classrooms with LAs, but anything more than 20 to 1 starts to get a little too dilute. 10 to 1 is the golden ticket, right? So FIU determined that 10 to 1 is awesome if you can get 10 learning assistants into a class, or I'm sorry, get 1 learning assistants per 10 students in a class.
Right, so even for small classes then, because we tend to think that we are the learning assistant for everything, right?
Right.
So 1 per 10, so this is,
yeah, I mean, totally. Yeah. If you can, because I know that a lot of animal sciences courses are around 100 or less.
exactly.
Yeah. And so it's a really fantastic way of getting students actually working in class on problems, because this is the application piece. And I can unpack that a little bit more if you like. But I want to make sure that we're getting you what you need and want before I go too far down a rabbit trail on learning assistants and specifically how we utilize them. Let me take a look at my notes and see which other one. Yes, I have something else.
I tried to do something like that when I had teach a service learning class. So have students from previous years, kind of a, but again, it's not official. They're invited. I guess if it was more official, so then they would be kind of coaching different groups, or I guess it would be interesting. But I don't actually do that. I do unofficially. So
yeah. So I just realized that I did want to share one thing, one idea on application for peer instruction, learning assistance, etc. And if you have a smartphone handy, consider looking up, let's see, it's called ABCD cards. That's what the app looks like. I don't know if is that reversed on your screen? I can't tell. Okay, it's good. And so this is actually what the app will look like. And so this idea of peer instruction, so a lot of folks will use clickers, right? Now, clickers are a fantastic resource and are awesome for peer instruction because you can pose a question, say, think about it for a minute, click in your answer, and then we get a live feedback with a histogram and all kinds of business, so we know what everybody chose, right? That's great if you have access to polling software or if you want students to use polling software. This is a free app where you can literally pose the question on the screen, and then you can, identify the answers as A, B, C, D, etc., and then ask students to go ahead and tell you what they think. And you can literally have them hold their device up to their chest, and they can pick which one that they like. or they can go to D. And see, the color here is really the key, because you can see this from in a 400 room class, or a 400 seat classroom. You can see this from way up front. And so if they're holding it up here, you know they're not doing the whole, what did the smart person behind me get? They might do that, but that's okay. But they're doing this, and we, the professor, can see if there's agreement across the class. Now, what do you do if there isn't agreement across the class? Well, when you're using this, it's a little tricky, because you see green, blue, red, you kind of have to do this kind of spatial thing where you're estimating. But if you see basically a 50-50 split, that's a perfect time to do a think, pair, share. So if you say, all right, here's a question, I want you guys to all give me your specific answer to this question, and I put up B, right? But I see that there's like B and C, just kind of, so they've thrown out A and they've thrown out D. It's between B and C. Well, I could just give them the answer, right? But we know from the literature that that's not what we should do. We need them to dig in a little bit deeper. That's when I say, okay, half the room's B, half the room's C. I want you to turn to each other and defend your answer. Because statistically speaking, they're probably sitting next to someone that has a different answer, right? So it's just a flip of the coin. So when you have that 50-50, then you ask it again. So you say, okay, now let's go ahead and come back together now. All right, now I want you to answer again individually. And then at that point, you hope to see all green. If you don't, then you wash, rinse, repeat, right? You figure out where you need to stop that process. Now, it may be that fewer than 50% understand this. So I'm going to actually flash my screen up here to, this is one of Eric Mazur's papers, in fact, and I'm going to see if I can, so we're focusing specifically on this, this figure right here. So he suggests a brief lecture and then a concept test where students vote. So that's just basically a question or a clicker question if you want to do it. And if you get 30 to 70% of the students get it correct, then you have them go to peer discussion, and then you have the students revote. Now, if fewer than 30% of the class gets it, you might need to revisit the concept. You might need to explain it a different way, or maybe come from a different direction. Now, what happens if greater than 70% of students get it right? Most of the room has the same color, little card here, virtual card. That means you can probably move on, but you want to make sure that you explain what that answer is, or give the answer and explain why it is that answer, because most of the room has it, and then you move on. That's a really great way to kind of measure formatively how to utilize peer instruction. So I did want to share that. I'm going to stop sharing that screen now, and I'm going to take a look at the chat just to kind of see where we are. Okay, thanks Neo for putting that in there. Great.
I have just a comment.
Sure. Thanks, Mallory.
I use something similar to that, except it's called Kahoot, K-A-H-O-O-T. I really like Kahoot because I can have it in small groups, individual people. And I've used it in several different scenarios. For example, like I would do a pre-lecture question or a post-lecture question, and then you can kind of add all of those questions together, and I would use it as a review before an exam. And what's really nice is the students can access it at any time. So if we have one day where we're doing a study review and then they want to go home on the weekend, they can go back and do that Kahoot themselves. So it's really nice. I don't know about ABCD cards, if they can go back or anything like that, but I thought I'd share that because the kids really seem to like Kahoot as well. And it's pretty easy to develop the questions and everything.
Yeah, no, I'm glad you brought that up. Kahoot is a great reference, good resource. The ABCD cards, that's all that is. It's just, it's not saving anything. It's not, they can't interact with it. This is just for a live class, really. I mean, you can actually do it. I mean, we've just proven just now that you can do this on your screen, but I don't know how well that would work because I can see every single one of you in your card. So that's not going to work that great. But yes, Kahoot is an awesome resource. Thank you. All right, so I want to continue and touch on a couple of other things. Specifically, I talked about cold calling. Now, I know that there are a couple of folks that I saw so I did a questioning seminar a couple of weeks ago where I talked specifically about different ways, different methods of questioning. So this will be familiar to many of you if you were in that session. But this is a very important evidence-based practice. So I'm going to go ahead and share my screen again. So this is Elise Dallimore. She's an associate professor at Northeastern. She's a communications expert. And she has written a ton of papers on Socratic questioning. So those of you that were in the other session on questioning will know that, you know, I mentioned that, so a lot of times Socratic dialogue or Socratic questioning has taken a bad rap over the years because of the way we typically do it. It's often thought of as punitive and put students on the spot and things of that nature. Well, I just explained a few minutes ago about how you can avoid maybe putting students on the spot by calling out 3 or 4 students at once and then giving them time to think about it before you ask them specifically. But I want to convince you with some data here on this, because I did not go through these data during the questioning seminar because I wanted to save them for this one. So what we see is that cold calling increases voluntary student participation. We know that it increases participation frequency. We know that it increases the comfort of participating in discussion. And we know that there's some evidence that it actually improves preparedness, which makes sense because if you know you're going to be called on, you're probably going to be more prepared, right? So those are some data. And here's some really interesting data on this in terms of gender equity. So Elise Dallimore did a 2019 paper where she looked at cold calling between men and women. And what she found was that cold calling actually increases participation equally between men and women. And she determined that in high cold calling environments, and what she defined as high is between 33 and 84%, that there were an equal number of questions answered between men and women. And in fact, this is the one that really got me the most. In low cold calling environments, women answered fewer questions. Now that may make sense intuitively, but to see some data on that is really kind of exciting to me because that tells me that we need to be doing this. And so this idea of students feeling uncomfortable or put on the spot, she didn't see any evidence of that at all. And she did a lot of surveys where students were allowed to give their perceptions and self-report on their feelings on cold calling, et cetera. And she determined statistically that, you know, neither group was really uncomfortable with the idea of cold calling. So basically, as I may have already given up the ghost here, but cold calling improved performance of men and women in class discussions, and evidence suggests that cold calling may make the classroom more equitable. And so that's really because you can be very intentional about who you're cold calling, right? So you can, if you're equally cold calling men and women, then you can be very purposeful in that process and make sure it's equitable. But what we find, as the first slide that I showed, the evidence is that cold calling actually increases volunteerism. So you really will only need to cold call a couple of class periods. I see that in my classes all the time. I start off cold calling, but then I don't need to after the first few class periods because they're jumping in. Even in these giant classes that I teach 300, 400 students at a time. Now, I already talked a little bit about how you warm up cold calling, you know, where I call on 3 or 4 students. I walk around the room. I let them know that I'm going to call on them. Everybody has the opportunity to really kind of, you know, get okay with that. They can also tell me at some point, because I'll say, you know, Neo, I'm probably going to call on you here in a couple of minutes. I want to be able everybody to hear what you had to say. And Neo has the opportunity at that moment to say, please don't, please don't. I'm really, really going to freak out if you do that. Then I can say, okay, maybe next time. So it's a really good way to get some discussion started. So I'll pause there. Let's see here. I want to make sure that we have time to share some of our own experiences. I could talk about this stuff forever, but I want to make sure that I'm giving plenty of voice for the room. Oh, Patty said, can you explain what low and high cold calling environments are? I don't understand the assignment of percentages. I would have to go back. It's been a little while since I looked at that paper specifically of how she defined those. I'm trying to recall exactly what her threshold was of low and high.
Well, what I don't understand is, like, what does that mean? Like 0 to 24% cold calling environment. Do you know what the percentage
of the questions that are being asked? So basically my recollection is that, you know, if she's asking, you know, are 50% of the questions she's asking have to do with a cold calling process, or are they just general questions that anybody can answer? So if she's asking, you know, 25 questions in that class period, a high cold calling environment would be 20 out of 25 of those questions were cold called questions.
Okay.
Or 5 questions out of those 25 questions would be a low cold calling environment.
And why is it significant that in a low environment, women answer fewer questions? Are they usually known for answering more questions?
Well, so this is, I don't remember if this wasn't specifically STEM that she looked at, but there are certain disciplines where women are far less likely to answer voluntarily. They will tend to take a back seat. And that is absolutely for sure in some disciplines. But the reason that's significant is that if left to their own devices, women tend to not engage verbally in a class. But if we're actually asking them to engage through a cold call question, they will usually answer, and in fact, usually answer correctly. It's usually a confidence issue.
Yeah, a lot of the gender research in all disciplines across the board show that women are called on less often because of implicit bias reasons, share less often, and assert themselves less often in the classroom environment than men do, or just because of socialization. Women see that as aggressive behavior or inappropriate in some ways. There's a lot of interesting research, and I would say definitely in male-dominated fields, more often we see them stifling their voices in different ways.
Thanks, Erica. Neo, thank you for putting in some of those data from your class. Yeah, so I'm part of the Learning Assistants Alliance, and I was at a conference a while back, and we were looking at video of learning assistants, in fact, and we were looking at 3 learning assistants and a professor in a lab environment, and they were discussing, actually this was a prep session for class, and so it was 3 learning assistants, and so laboratories or benches are usually in 4s. So professor in one corner and 3 other students. 2 were men, 1 was a woman. All learning assistants, all ranked equally, if you will, right? What we saw in this particular video of them discussing it is that every time the woman spoke up, somebody would step on that woman. They would interrupt her, they would whatever. And it was really staggering to watch that. In fact, so I actually use that in the training of my learning assistants here at Texas Tech. And I start off and I just say, everybody, let's watch this video, and I want you to take some notes on what you notice. And what's really interesting is that nobody notices it.
There's a lot of fascinating research around this, like in faculty meetings as well, and just different things that, like, that's where the term mansplaining comes from, is like a woman saying something and then a man coming behind her and saying the exact same thing or the exact same idea, and then getting a lot of attention. And so anything we see in the larger culture happening is going to happen in our classes, because they're little microcosms for our things. It's really fascinating to see and observe.
Yeah. Thank you, Erica. So we have about a minute left. And you know, there's a lot to talk about with evidence-based practices, and I wanted to give you a few ideas. So we talked about peer instruction, we talked about cold calling. These are things that don't take a lot of practice. You can implement these right away. You can try a think, pair, share tomorrow, and this works on Zoom. It does. You can sort your students into breakout rooms. And if you've not learned how to do that or figure that out, I want to refer you over to Erica Brooks-Hurst. She is kind of our doctor of Zoom in the TLPDC. That's not an official degree yet.
That's my official title. Yep.
Yeah,
I'm calling it.
Yeah, we don't have an official degree plan for that yet, but we're working on it. And so if you want to learn how to do some peer instruction using breakout rooms, Erica is a great resource. She has several YouTube videos that she's already created on our TLPDC YouTube channel. And I'm sure I'm going to go ahead and let you know you can reach out to her as well.
If you're having trouble with that, just email me. I'm happy to visit with you further. If you've watched the video and you still don't understand it, we can just jump on and play and try it.
All right. Well, thank you all for joining us. I hope that you got something out of this. You know, maybe it's some things that you've heard before, but you just maybe want to know a little background on it. So please reach out to me if you have questions or you want to see some of these data or more papers, or hear about more techniques and the evidence behind those. I'm happy to share that. I live for this stuff. So just let me know. I want to thank you all for joining me, and I will see you soon.